No recording. So again, we definitely want to be familiar with all the different ways of writing a quadratic equation. That's probably the most typical way. We call it standard form because it's just, again, the most traditional way of writing a quadratic equation. It's a polynomial, many terms. The key thing is you have to have an x squared, otherwise it's not quadratic. It doesn't have an x squared. So if a were 0, then if you have like y equals x plus c, then that's just a linear function. Hey, Jonathan, welcome. Of course, if a is greater than 0, we expect the problem to open up, like you see right here. If a is less than 0, it opens down, like you see right there. Obviously, if it's opening up, then the vertex represents a minimum. If it's opening down, the vertex represents a maximum. So just some basics. Axis symmetry. Kind of good to know that negative b over 2a is the axis of symmetry. Some people kind of like try to memorize the form and forget. The way you can actually understand why this works, quadratic formula is something that most people do know. That we kind of beat that into you guys over and over again. And then what the quadratic form represents are the x-intercepts, right? So like if you have a quadratic equation, like hypothetically speaking, let's say I have that quadratic equation right here, right? Now actually I know how to, this is actually factorable, so it's kind of easy to solve. X plus 1, x plus 4 equals 0. And if you set each of those factors equals 0 and solve, you get two answers, -1 and -4. Voila, right? If I plug this in the quad form over here, I'd still get the same thing. It's a little more labor intensive, but I will still get the same thing, right? Well, here's the thing with quadratic equations. When you have x-intercepts, and don't mind the background noise, my son's crying over something. I don't know what he's crying over. So anyway, and we still have the rat in the backyard. I think we're gonna catch it today. We put two traps by the, he hangs up by the lavender bushes and the citrus tree, and we put two traps. We didn't arm the traps. We put peanut butter and jelly sandwiches because that's what he had last time, and he ate it, both of them today. So now it's conditioned. So we're gonna now actually set the traps so we kill him.
Actually, sorry. Have you tried like gluing like
Yeah,
this?
but it's a pretty big rat though.
Oh, okay.
I
Okay.
don't know if it'll work, but yeah, but I have the glue traps.
Do you have the glue? Sorry, it's because I live right behind a Wingstop. So we kind of had this problem like recently because of like it was like shut down for a minute. So like they were like looking for food, so they were going through like all of our like my house and like our neighbors.
Sure.
Have you tried the glue traps? Those are pretty powerful.
Yeah, they are. Yeah, actually, you don't want to touch them. I do have them. Actually, I'll probably put that out as well.
Yeah, those,
Yeah,
I think.
I think now that the rat's kind of conditioned, I might add that as an extra thing.
Yeah.
So yeah, I do have it.
Yeah, you can try that. I think.
Yeah, I have a pretty. I don't have it back. I have a pretty heavy duty, two heavy duty ones. But you gotta be careful when you arm it because
because then you get stuck and then you can't go nowhere.
Yeah, but at least now it knows it's safe to eat the food, so I'm gonna now arm it. So anyway.
Yeah, and glue it. Yep.
Yeah. So I digress. Sorry. Yes, talking about sun crying and rats. Now let's get back to math. So anyway, x-intercepts, right? That's what we have here for this equation, -1, -4. Because that's what they represent when you set the equation equal to 0, because you're kind of letting y equal that equation, right? Or that expression. And of course, y equals 0 on the x-axis. Now the axis of symmetry, of course, would be right in the middle. In this case, it would be -2.5. Well, if you think about it, that's just the average of these two numbers here. You know, if I add them up and divide by 2. So wouldn't I want to just do the same thing over here, right? If -b plus root b squared minus 4ac all over 2a is one x-intercept, and the other x-intercept is -b minus, let me erase that, -b minus b squared minus 4ac all over 2a is the other x-intercept. Obviously, if I add these two, these radicals are going to cross off, leaving with -b over 2a. But because it's an average, you got to divide the whole thing by 2. 2's canceled, but you divide by 2 again. That's why -b over 2a always represents the x coordinate of the axis of symmetry, or the x coordinate of the vertex. Sometimes we kind of just tell it to you and no one really kind of understands why, but now you kind of gone through quadratic functions in Algebra 2 class. Remember, if you have your x-intercepts halfway between the axis symmetry, that's where the vertex will lie. And if you were to take the quad form and average the two x-intercepts, negative b plus square root b squared minus 4ac over 2a, negative b minus square root b squared minus 4ac over 2a, and average that, you would get negative b over 2a. So hopefully that kind of sticks with you, why negative b over 2a is the x-coordinate of the vertex. Once you have that, you can throw it back into your equation to naturally get the y-coordinate of the vertex. So this is kind of just some review of quadratic functions. To get the y-intercept is easy. That's just when x is 0. Obviously, x-intercepts, again, we already talked about that. That's when you replace y with 0, and either through factoring or quad form or another technique, you get your x-intercepts. So I kind of think beat this to death here. So for number 1, yeah, hey, find me the y-intercept, plug in 0 for x. You can see it crosses at 0, negative 2 anyway. Find the axis symmetry. So now we know about the negative b over 2a thing. So you locate a, b, and c. A is 1, b is 2, c is negative 2. Throw it in. Find the coordinate of the vertex. Obviously, once you get the x-coordinate, you get the y-coordinate. And of course, it's a minimum because it's opening up, so the vertex is the low point. For 2, it's kind of more the same thing, but it's already factored for you, so you can find the x-intercepts pretty easily, negative 2 and 4. And then take the average of the x-intercepts to get the axis symmetry, and of course, get the y-coordinate of the vertex. And then, because it's opening down, then the vertex represents a max. So I'll probably do maybe number 1 and 3, because those are multiple choice and free response. And this graph here goes for 1 and 2. So for number 1, they give you the equation. Okay, great. And then they're asking you which of the following can be an equivalent equation, but one in which a vertex is identified as a constant, meaning that we can locate the vertex in the equation itself. Well, the vertex here, I think it's pretty obvious. I mean, it's 3, negative 4, but your x-intercepts are 1 and 5. You can factor it to prove it. So halfway between 1 and 5 is 3. If you throw 3 in the equation, you do get negative 4. So you're looking for 3 and negative 4 in the equation itself. And that's why you get D. And this is vertex form, by the way. So that's another form we need to be familiar with. Not just standard form or something that's already factored, like these are factored, obviously, but this as well. And that's involving translations, which is a big part of algebra 2, like shifting graphs, right? So we shift like, 3 right, 4 down. So there we go. For 3, they want the y-intercept. So you have the x-intercepts, and then you have the equation, because the x-intercept so happens to be our vertex, by the way. They don't have a plus k here, so you assume k is 0. So, but I don't know what a is. Actually, sorry, they give us y-intercept. I lied. We have to solve for a. So if the y-intercept, of course, is straight up 9, then guess what? X is 0, y is 9. Throw it in. And you're golden, because then you will solve for a. 9 equals 16a. A is 9/16. And you would just grid that, in the pre-response portion of the answer sheet. So those are just good review problems of quadratic functions. Again, if you're doing pre-cal, you're going to be doing a lot of this. Calculus, we expect to kind of know this really well. So definitely you guys will do 2, 4, 5 in just a tad. I'll let go, welcome. So we actually got 5 of you guys here. So definitely we'll do 2 breakout rooms. So 2, 4, 5 we'll do in your breakout rooms in a little bit. Let's talk about factoring, since I did talk about factoring just a little bit in the previous section. So if you're factoring something pretty basic where you have x squared, you don't have a coefficient next to x squared, so you assume the coefficient is 1, then factoring should be pretty straightforward. Like in this case, you just try to find 2 numbers that multiply 20 and add up to 9. That'd be 4 and 5. And they're not infinite possibilities. I mean, it's pretty confined, like 1 and 20, 2 and 10, 4 and 5. Of those 3, one of those 3 should work. None of those 3 work, then it's not factorable. Like if you look at B, you know, they kind of go through all the possibilities. And of course, we're going to go with the middle one, -2 and -9. If you look at C, you try to find two numbers that multiply -14 and add up to 5, that'd be 7 and -2. So you got that one right there. Some trinomials are a little bit more intense, like when there's a number next to x squared, which is not 1. So you could do a little bit of trial and error. Remember, this is multiple choice for the most part, so you probably could just work backwards, or if it's in a calculator portion, you could just graph it, but my guess is it'll be non-calc and probably maybe free response. Let me kind of show you one technique I tend to use. I do a little diamond or X, put A times C and B. Remember, that's A, that's B, and that's C. So I'm deliberately going to multiply A and C, which is 12, and put B down here. And your job is to find two numbers that multiply to 12 and add to -7. That's our job here. So what's multiplying to 12 and add to -7? You kind of go through a few possibilities, but -3, -4 would be it. So and that's exactly what they're saying here. Sum of -7, product of 12. And then notice that they split the middle term. So instead of writing -7x, they write as -3x minus 4x. That's the whole point. If I erase this stuff here so it's not too distracting, use red. You group the first two and last two terms, and you try to find common factors. Like I can factor out an x from the first group, and it looks like a -2 from the second group. And because these are identical, which they should be if you're doing it correctly, x minus 2 is one factor, 2x minus 2 is the other factor. Now you have it factored. If they ask you, hey, what are the sum of the factors? What are the product of the factors? Or sorry, the sum of the zeros or product of the zeros. Your X-intercepts or zeros are 3/2 and 2. And then you can do whatever you need to after that. Or if they just ask you to factor it, great. Or to solve and set it equal to 0 and solve, that's fine too. So there's a whole bunch of other ones here that kind of follow the same process. I don't think we have to go through each of these. I don't think that's really the best use for our time, but let's do, yeah, these are all pretty straightforward. This should go by pretty quick. I'll just do 1 and 4. So I could kind of just work backwards, I guess. I don't know if you'll see one. This one would probably be like one of the first. It would be too easy, I think. You could just work backwards, right? Like I need to multiply -24, but add to -2 in the middle. So it's going to be C, because -6x and of course 4x. Number 4, we need to add to, well, we need to get 3x squared. We also need to get -6, which you all do. But I need to get 7x in the middle. And it's going to be A. I got kind of lucky by looking at that one, because 3x times 3 is 9x, -2x, you get 7x in the middle. The other ones will not provide us with positive 7x in the middle. So that's why it's A. Don't know if you'll quite see something like that. I think they'll probably say, hey, here's the polynomial. What are the product of the zeros, or product of the X-intercepts, or they'll do something else. So it's still good to know that skill of factoring. But in these cases here, you could just work backwards. So I think now's a good time to do a little bit of a breakout room. So we'll do 2, 4, 5 of the first section. Remember, I already did 1 and 3, so 2, 4, 5. So it should take probably about 3 or 4 minutes to do those 3 problems. And this should go by pretty fast. 2, 3, 5, 6. That should probably take about 2 or 3 minutes. So I'll probably give you guys about 8 minutes, let's say, to go through those problems. So again, 2, 4, 5 of the first section, 2, 3, 5, 6 of the second section. When we come back, we'll quickly go over it, and then we'll keep moving. So let me stop sharing, stop